Hey guys, here are the problems that we couldn't get to in class. Good luck studying, but this should pretty much, after you do these problems, you should be pretty much set. So first problem, I'm going to do these pretty quick. If you need me to slow down, just pause it, and then I'm going to keep going, but just play it when you can play it. First thing we're going to do is always distribute. So we got 15x plus 5 is equal to, I'm going to distribute this to 26x minus 6. Then let's move our variables to one side. So I'm going to subtract 15 because that's a positive 15x on both sides, and I'm going to combine it with the positive 26x, which leaves me with 9x. I'm sorry, 11x minus 6, which equals 5. Now I'm going to add 6 to both sides, so all my numbers are isolated on my left side, and I have 11 equals 11x. Finally, I'm ready to solve, so I do the inverse operation of dividing by 11, and I'm left with 11 equals x, which is x equals 11. Next one. First thing we're going to do is I noticed that there's a lot of stuff on this side of the equal sign that I could combine. I have a negative 2a and a positive 3a. Well, those could combine just to become 1a or just a. And 4 and negative 7 combine to be negative 3, which equals 4a plus 4. Now I'm ready to just move my variables to the same side. So I'm just going to subtract an a, or 1a, on this side, and subtract it on that side, which leaves me with negative 3, which equals 3a plus 4. Subtract 4 on both sides, which leaves me with negative 7 equals 3a. And last, I'm going to go ahead and divide both sides by 3. So you're left with a equals a negative 7 over 3, which is an improper fraction. We could leave it like that. We can do the mixed number, which is 2 and 1 1/3. And if you really wanted to, you can divide 7 by 3, and that would mean a is about the negative, and then you could write the decimal right there. And notice that I'm using the about sign because I'm going to end up rounding my decimal. Oh, I'm sorry, it would be negative 2 and 3/10. You wouldn't actually have to round because you could put the line bar notation over it. So x actually equals this exact decimal. All right. Next one, there's some distributing. So I'm going to distribute the 4 on this side. So you get 32 minus 12w equals 32. Now see, there's distributing here. But you want to make sure you use the whole number, which is negative 8. So when you do 32, and negative 8 times w is negative 8w, so minus 8w. Negative 8 times 2 is negative 16. Then I could combine those things because they're on the same side of the equal sign. And 32 and a negative 16 combine to a positive 16. I could either write 16 minus 8w. I could have written negative 8w plus 16. Bring down my equal sign. 32 minus 12w. I'm going to add 8w to both sides. Leaves me with 16, which equals 32. And negative 12 and positive 8 would be negative 4w. Subtract 32, which leaves me with negative 4w, which equals 16 minus 32 is a negative 16. Last, because they're multiplying by negative 4, I'm going to divide both sides by negative 4. I have a negative divided by negative. W equals positive 4. Okay. Here's the number with decimal. If I really wanted to get rid of the decimal, I can multiply the whole thing by 10, as long as you do every single number. But I'm just going to keep the decimals, and I'm going to first add a 1f to both sides, which will move it to this side. So 1 and 4/10 f plus 1f would be 2 and 4/10 f plus 1 and 1/10, which is equal to 8 and 3/10. Subtract. Notice that I'm lining up my decimals when you subtract decimals. And then obviously you can do this on the calculator, but everyone here should be able to do this without a calculator. To divide 7 and 2/10 by 2 and 4/10, so that would look like this. Move the decimal over, and bring it up. 24 goes into 72 3 times. So f is equal to 3. Okay. Last one, we have one with fractions. So we talked about if you have a bunch of fractions that you just don't want to deal with, we're going to multiply every single thing in here by a multiple of the denominators. So 8 and 2, you can actually multiply by 8. So 1/2, so we're going to multiply 1/2 times 8, and you get 4x. Negative 5/8 times 8 would be negative 5. 7/8x times 8 is 7x. And 7/2 times 8 is 28. Now we can just solve like normal. Don't forget the negative sign. Move the 28 over by subtracting it on both sides. You're left with negative 33 is equal to 3x. Divide by 3, you're left with x equals a negative 11. Okay, this is the last one. I'm sorry, there's two more. Distribute. Now I'm going to add the 9x to both sides, but what happens when I do that is the x's totally cancel out. I'm just left with the negative 6, which equals negative 4. That is not a true statement, so there is actually no solution to this problem. There's no number that you could put in for x to make this work. Last one, distributing first. 2a minus 16 plus 7 is equal to 5a plus 10 minus 3a. Notice that there's numbers that I could combine on the same side. You got a negative 3a and a positive 5a. 2a plus 10. Here you have 2a and negative 16 plus 7 ends up becoming 2a plus, minus 9. And when I subtract my 2a's from both sides, the same thing happened as before. And I'm left with negative 9, which equals 10, which is, again, no solution. Now, had you ended up with 10 equals 10, then that would have been all solutions, all real numbers. But here, there's nothing you could put in for a to make those two sides equal. Hope that helps.